All right. How does this look? I'm hoping everyone can see this okay. Um, thank you so much for the people behind the crowd for putting this together. And thank you so much for having me as a guest, letting me bore you guys a little bit with SSRF. For those of you that may not know me, I'm Ben Sadegapur. A lot of people know me as Nahamsec. I am currently the head of hacker education at HackerOne, and I'm also a hacker on HackerOne's platform. I'm somewhere in the top 20, 12, 13, something like that. I've hacked Snapchat, Verizon Media, Department of Defense, Airbnb, Valve, Rockstar, and a ton of other good companies doing bug bounties. I also make educational content on hacking on YouTube, and I stream hacking on Twitch every weekend very regularly. And if you're in the home and you're out there, you know what to do. It's just some F in the chat, boys. Also, a big thank you to Cody Brocious. We originally did a smaller version of this talk at DEF CON together, and Cody was a huge, huge part of that research. And if it wasn't for all of his contribution, this talk wouldn't be possible without him. So I want to make sure I get that out of the way. We created some really cool tools and some very cool POCs thanks to his research and mine together. So let's jump into it and let's talk about SSRF. But before we do, if you are a developer, you work at a company, you may have received something like this from AWS. This was triggered from right after we did our talk at DEF CON. They sent out an email saying, hey, you have a PDF generator. Make sure there's no HTML being rendered in it from the user input. It was a fun email to get, but please, 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 if you are someone who's in charge of some product, don't email AWS, don't email GCP. It's your responsibility to make sure you are parsing your user input properly. So again, please don't go bother people at GCP, Azure, and AWS over this talk. Before we jump into SSRF, we got to understand what it is. OWASP has this giant paragraph on what SSRF means, but to kind of shorten it, a TLDR is you have the ability to point the target server that you're hacking on, or the whatever application or whatever server is running an application. You can request internal hosts and files like a browser. So imagine having a browser on a server that belongs to another company, and you can point that to files and also internal hosts. And if you're not sure what the cloud metadata is and why AWS and GCP are involved, is because all these cloud platforms, they give you this internal IP where you can hit it and you can receive some internal information like internal IP, host, project details. And if they have not fully done their permissions properly, you can also get the access key and secret key as well. So that's the point of SSRF. You know, most of the hackers, especially with bug bounty programs, when they get SSRF, they want to go and right away look for access keys and secret keys to that cloud instance. And this IP address makes it very, very easy, especially if you have not done the permissions properly. So let's talk about a basic example. Think about it as you go to this website, you sign up, and it says, hey, you can either upload an avatar or you can actually fetch this avatar from another website. So if you go and fetch the avatar from another website, you give it a URL and you say, here's my funny cat meme that I want you to put as my avatar. And in the background, it makes a GET request to the API, to the path, whatever the file name is. In this case, we call it fetch. And it puts in your URL site.com, my funny cat meme in there. And obviously you can change that. And if it's being rendered server side, then you can point it to things that it may have access to internally. So in a lot of cases, that cloud metadata IP that I pointed early on. And it's not always HTTP. It could also be protocols like File, Gopher, SSH, and so on. So you can use a lot of fun stuff depending on how the application is built. And it's always not as easy as I just pointed out. There's always some limitations, but we'll talk about them in a little bit. So let's talk about some CVE examples. Previous to my last slide, this is a CVE that came out 3 years ago. And unfortunately, some organizations are still vulnerable to this because they don't realize that just because it's not really internal, or just because it doesn't look valuable to them, they don't choose to fix it. But again, you go to this endpoint icon URI, you change the consumer URI to whatever value you want. In this case, Alyssa, who I took this from her blog post, is pointing it to Google, and you can see it's loading google.com. But then you change that IP, that you change that consumer URI to an IP, which is a cloud.IP, and it's giving the internal host name for it. And this was on the DoD property that Alyssa had originally exploited by finding a publicly accessible Jira. The next one is a CVE that came out from Orange. Orange Sci has been doing some really, really cool research on SSRF, and this was one of them where he found out that if you point this giant path, if you change the API URL and point it to anything internal, including the AWS metadata IP in the source of the page, not at the actual page, but if you look into to the source, it shows you the response for it as well. So these are also things that I've seen internally be vulnerable at some organizations. In a lot of cases, you can also chain these. So if you get a limited SSRF that only does GET request and you find an internal Jenkins instance, this is a perfect way to chain your exploits. And I've done that a ton of times with Jenkins and Jira and Confluence. So there are a ton of good CVEs, but these have been very, very popular amongst the people that are doing bug bounties, especially. So again, as I said earlier, it's not always this easy. There are a few things when it comes down to SSRF that you will probably face in a lot of cases. So the top three ones that I've put up is, the first one is the metadata or any internal IPs that you put in are getting filtered. They have some sort of a white or blacklist that takes care of that issue. It's their permanent fix. Sometimes you can point out a subdomain of your own. You create a record and you point it to the IP address, and it completely ignores the whitelisting. So that's been something that I've done in the past. When I put in the IP address, it doesn't work, but I point awsmydomain.com to the IP address. Sure enough, it works and gives me whatever I need. The second one is there is times where the company is doing some whitelisting. They only allow their domains and subdomains. In that case, you can find an open redirect. Please don't burn your open redirects if you find them. It's not worth the $100 payment. Maybe you can use it for SSRF later on if you do find one. And of course, there's a third one, which will also show an example of it with Snapchat, is where you have an SSRF, but you can't really see the output. All it comes back is with an OK or, task done, something like that, or a file uploaded, but you can't actually see the data that it's, that when you point it to, the internal IP addresses. You can use JavaScript in some cases and exfil some data as well. A lot of things are really important when it comes down to SSRF, but the most important one that I want to make sure I highlight is, please, 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 the first thing you should do is get the user agent, because you know what backend they're using and how you should approach it. You can Google that backend, and see if there's already known vulns. And three, when you get the UA, it also gives you the IP address, so you know if it's hosted on GCP, if it's hosted on AWS, or is it is it coming from the server, or is it coming from your browser when you make that request? So those are things that you want to make sure you have before you even think about exploiting SSRF. And then last but not least, I talked about the redirect thing, but the last thing is, if you see any customization with HTML or CSS in a PDF generator, for example, if they let you customize the headers for your company name and logo and stuff like that, those are 9 out of 10 times vulnerable. So look out for those as well. So let's talk about PDF generator. There are a ton of ways. I'm going to go through this a little bit faster because I realize I'm a little bit short on time. There are two ways you can do it. You can use some of these libraries and backends that are out there, or you can use headless Chrome. Both could be vulnerable depending on the configuration. And again, there are a lot of wrappers and libraries out there, but we'll cover those later. One of our favorite ones was WheezyPrint. We also own WheezyPrint as a part of this research, but WheezyPrint is a great example of whatever HTML you give it, it literally puts it into a PDF and then it spits it out to you. So if you're not sanitizing whatever is in that HTML form that's being presented to the user, it goes right into the PDF and presents itself to that user. So how does it look? Let's say you find XSS, you go to that same page, it says export as PDF, you export a PDF, and sure enough, your script document, right, 123 shows up as 123 in the PDF. It's a good indication that you have SSRF. So let's look at how it works. For a lot of cases, the first thing that I do when I see a PDF, I try some HTML. I put, H and the underline tag, and if it renders it in the PDF, there's an indication that I can, push some HTML in there. And obviously, I will use things like iframe or image, something that would force the application to fetch an external file from my server just so I can leak the user agent. So this right here, you can see I have the user agent and they're using the WK HTML to PDF that I mentioned early on, and ways you can make PDFs. And of course, in some cases, it's super simple. You just make an iframe and you point the iframe to an internal IP address or a file sometimes, and sure enough, it comes back and gives you access to it. But that's not always the case. We'll talk about some more complicated ones in a little bit. So one of the most simple ways to get this is the styling that I mentioned earlier when I was doing my intro. So we had this company where most of our user input was getting sanitized and filtered. So no matter how many times we tried, anywhere we could put our user input, we put HTML in there and it wouldn't render. We had no XSS, no HTML injection, nothing. But the site did allow us to do some font and styling. So this is how it worked. We would go to the documentation. It says pick a font, pick the size, pick the color right here. And you pick him, you send save. And right after you save it, this request gets sent. And we just thought, what if they're using HTML to all this? Because this is all CSS, right? So what if we just close the style tag and see if the rest of it would leak into the PDF? And you can see we have had tests a bunch of times right here. There's the ASDF that wasn't rendering. The test right here wasn't doing anything. But you can see as soon as we put the style tag up here, everything else from the CSS after it was leaked into the PDF. And this is the header of the PDF where our logo and company address that you can see is linked. So sure enough, you go pop back in there, you post a image and you say, hey, I want you to fetch this remote image from my server that I'm hosting on my box. And I want you to fetch that file. And when you do that, it leaks the IP address. And it also gives you the user agent where it tells us, oh, this is Java. We are going to need to do either put some Java into the PDF instead of HTML and see if it does anything, or we need to look and see what kind of protocols are allowed when you are going after a Java backend for a PDF generator. But for our case, it wasn't that hard. Lucky for us, all we had to do was do a style iframe, point the iframe to another to the internal IP address, and sure enough, that gave us whatever we needed, which is the access key and their secret key as well. There has been times when I've seen this where the IP directly didn't work, but we had just a PHP file on my web server where it would just do a header redirection to the IP address, and we used that trick in the second time around to exploit it. So I've seen both of these work. Sometimes the IP address doesn't work. Sure enough, you do a redirect, and it changes everything. It's a game changer in a lot of cases. And again, like I mentioned, please make sure you're not burning your open redirects. At least if you find them, hold on to them for a little bit. It's $100. It's not worth it. You may find it valuable towards the end of your hacking. But it's not always this Wheezy. I mean, it's easy. Wheezy print was one of the ones that was really, really hard to exploit for us because no matter how much we tried, we couldn't understand this PDF generator. We were working on a service that required us to trigger a delivery of some sort in order for the PDF to be generated. So we were very, very limited. And we couldn't get the user agent because we were doing it on a mobile phone, and the encoding of the double quotes was being weird on the phone, and then we didn't catch it until later on. But once we figured it out, we realized that we couldn't run any scripts, we couldn't load any iframes, we couldn't, but we could load images, but that's kind of boring, right? Who cares if I could load a favicon from localhost? It shows access, but it's not critical. We want to have the highest impact possible when it comes down to these SSRFs. So once we got it to connect, we realized that it leaked the user agent as being WheezyPrint. We did a quick Google search, and by doing our search, we realized that WheezyPrint is completely open source. You can go on GitHub and look at exactly how things work. And before I show how we exploit this, I wanted to show what WheezyPrint does. So the way WheezyPrint works is you type in WheezyPrint, the input HTML that you want to create a PDF, and you give it an output for it. So if I have input.html, that's whatever template I'm using. It's going to make that into a PDF by calling it output.pdf. So in our HTML file, I put a ton of tags you can see on the left. The only one that did actually work was the image source. So it fetched the source from, the image from Google's favicon, But again, that's kind of useless because it's not giving me any privilege. It's not giving me any sensitive data other than whatever this internal host is running. So to recap everything I said, we had no JavaScript, no iframe, image worked, it was boring. We tried embedding files, we tried objects, but we realized in the GitHub repository that there's this thing called the link. And we weren't sure why a PDF generator would let you use the linked HTML tag. And the way the link HTML tag works is you can tell it to you want to attach something, you can make the source of the attachment be an internal file. And this actually did work on them, but we got very lucky to catch this because when we were doing this, Cody accidentally typed in the wrong file name where it attached a video file that was 4 gigs big. It was a huge, large file, and it took a very long time for the PDF to be generated. And when we did the LS, we realized that the file was huge. So when we went through our history, we realized that we attached the wrong file that was huge, and therefore that was the reason why the output PDF came out a lot bigger than a text file. So that indicated that there was something there, but when we open up the PDF itself, it wouldn't show the content of the file. So it turns out you actually would put this in the metadata, and you can actually pull that out by using zlib in Python. And of course, if you can do a read file like file.etcpassword, you can also make web requests to things like the AWS metadata instance. So quickly, we popped that in there. We pointed it to etcpassword. We downloaded a PDF. We fed it to our decompiler that we wrote, if you want to even call it that. We pulled the content of etcpassword, and then we switched that out to 169.254.169.254, and it showed that we also have access to internal resources. And we put it out to them. Unfortunately, I can't disclose who this program is, but they're promising me in the next month or so to completely disclose this vulnerability as a part of their bug bounty program when it goes public. So look out for that. There's a really, really cool video that hopefully will come out with it that explains the whole thing. And I've also done a video on this if you want to see the details of how WheezyPrint works on YouTube. You can check it out. So DNS rebinding, that's another one that was huge. This was the one that blew our mind because we understand how it works, but we don't understand why it happened. So the way it works was if you have ever hacked on a program that is hosted on GCP, you know it's not easy to just hit GCP on its own. So you can't just make a request to user data. It doesn't work like that. You have to do some funky stuff for it to work when you load your remote server. So you point your browser to the domain. It doesn't work, but what we found out is if you make 2,499 requests, it flushes the DNS shafts for the original domain, and it lets you actually access the metadata instance if you change the DNS name halfway through. And I'll show that looks like in a little bit. So to give you an example, we did this exact thing that I have on the screen. I'm going to show you guys a video of it and kind of talk over how it worked. Let's see if I can do this. Okay, so here, as you can see, we're on snapchat.com. This is in prod Snapchat, actually, because I like to test in prod. When you go to ads, it lets you create your own ad. You can upload files, branding, whatever you want. When you click on the logo, you can replace it, or you can actually import it from another website. So this will import the entire site into an ad for you. And when you click import, it makes a request to their API, which will show in here. There we go. So what we do here is instead of pointing it to Google, we're going to point it to Dakin's server where our HTML file is hosted, where it hooks to JavaScript, and he's doing a Python web server with Flask. As soon as it hits our server, JS points it to another domain where it's right here. It's the MD one, and we're going to change the IP address from daemon to the internal IP address for AWS, and let JS do a few loops, which takes about a good few minutes. And after it makes the 2,499 requests to AWS or GCP, at the end, I'm going to play it one more time. As soon as it makes that number of requests, the host name, the auth token, and SSH keys for that box was leaked to this script. So the way it worked is we had it hit the server, initiate JavaScript, JavaScript makes a wait, it gives it a wait time of 30 seconds. In that 30 seconds, we popped over to our um, DNS records. We changed the IP address to the internal IP address, let it do its thing, and then eventually it spit out the entire secret. So let's go back to the other avenues of doing that. That video is also on YouTube if you want to keep watching it and to understand it. The tools that are used in this, I will also talk about them at the end of the talk, which you can use for free. Next one is this is something that I worked on later on. I found an XXC through an SSRF because every trick that I had up my sleeve wasn't working. There was no open redirects, there was no local file read. I couldn't get any HTML XSS in there. And there was no problem because we also have other ways of doing this. So again, image worked. I used the image tag to point it to my server, and sure enough, it leaked that the user agent was Prince version 10. And if you do a Google search of Prince version 10 and you put the word exploit next to it, the first thing that comes up is CVE 2018 19858, which is a XXC of some sort on Prince v10. And the best part of all this was I didn't even have to really reverse engineer what this vuln was because another bug bounty hunter, Corbin, had already figured this out on his own. So reading his blog post, it turns out that exploiting this a lot easier. I just wasn't looking at this at the right way. So the way it worked is you actually could use an iframe, but it would only work if it's being pointed to an XML file and it actually renders the content of the XML. So this is a demo that he had because I couldn't share mine, unfortunately. All he's doing is he's pointing um, the PDF with iframe to the XML file, and the source code for it is up on the screen. And the XML file actually calls over to the internal metadata IP address, and that gives us access to the keys again. So very simple and easy. You just have to realize that just because your traditional tools aren't working, there are other ways that you can actually exploit this. You just have to think about it differently and not always limit yourself to doing XSS and trying to achieve it through just HTML on its own. The last one, and this is one of my favorites, is we actually had this PDF thing. We thought this is SSRF, but turns out it's not SSRF from the PDF generator. It's a template injection of some sort. So what we did was accidentally, instead of doing our traditional HTML, and I know a lot of things that I say happen on accident, it's by luck, I guess, we added a payload that does some math stuff just to see if there's any templating. And of course, the first one worked. We thought this was some sort of a Java reaction because it was coming back as Java, but turns out Cody had actually dealt with this in the past. So when we showed this to Cody, he came back and gave us a few payloads to run, and then when we did self class name, it returned PDF view context, so we could confirm we can run some sort of a code on here. We just were not looking at this um, the right way. Again, we were just so focused on XSS through a PDF to access the internal stuff that we weren't thinking about templating and actually template injections. So easy enough. We escalate this to RCE. This is again the styling tag that I showed earlier. We give it some random stuff, and then we gave it the command ls, and sure enough, as you expected, it returned another piece of information that was the directory listing where the PDF was being generated. So again, don't limit yourself to just SSRF when it comes down to PDF generators. That should be your first go-to, but it's not always the only solution. Try other things like XXC, try template injection, see if you can get other entry points into the PDF to make it do whatever behavior that you need it to do. And of course, that comes with profit and tons of money if you're doing these for bug bounty programs. Out of this talk came out a couple of good and cool tools that Cody wrote. First one is the HTTP rebind. This is the exact tool that we use for the Snapchat POC that I shared earlier. If you don't want to write your own script that does it, you can use this. And we've made sure it works for GCP, AWS, and Azure as well. The next one that we put out together is SSRF test. This is just a all-in-one SSRF toolkit. You point the vulnerable endpoint or the PDF generator to this instance, and what it does is it throws a ton of payloads at it to see which ones work and which one doesn't, and if it pulls information, it will let you know. I personally don't use any tooling for SSRF, but I know Cody has pretty much wrote every possible way of exporting SSRF into this thing. And if you don't want to use the ssrftest.com instance where he has put it online, you can actually download it and put it on your own web server and use it as well. So you have both the option of using his service or just setting up your own. To do a recap, uh, SSRFs can be dangerous. It sometimes takes a long time to understand how these things work. For example, WheezyPrint took me about 3 months to piece together because it also required me to use some random services. If you see a PDF generator, 9 out of 10 times it's vulnerable. In a lot of cases, it may not be obvious, but you have to find the entry point. So find out where can you put any user input, the different places where you can put your input, and check every single one of those for HTML injection and template injection and see which ones work. XSS and open redirects and all those other exploits could also be used in this case. So think about your entire your entire workflow should be around owning the PDF generator instead of the actual web app. And just because you get an XSS that doesn't work on the actual application, it doesn't mean that it won't get transferred over to the PDF. There's been a number of times where I put HTML on a website. In my profile, for example, for my name, it doesn't render on the site, but I go to the PDF, and sure enough, it was rendered in the PDF. So look out for those. Disable JavaScript. We don't need it. I don't know why you would want JavaScript in PDFs. Create some really strong whitelisting. And then, of course, properly configure your cloud instances to minimize the impact. And last but not least, if you are a security engineer behind a bug bounty program, be nice to hackers. We're just here to own your stuff and put you on blast. I'm just kidding. Just to report you, want to report to you and make your stuff more secure. So please be nice to all the hackers that are trying to get in touch with you. And last but not least, a big thank you to ThoughtCraft for having me. I appreciate you guys letting me be a part of this. And also a big thank you to Orange, Alyssa Herrera, Shubs, Zayed, Daycan, and CDL for letting me use some of their content throughout this presentation. That's it for me. If you guys have any questions, again, I'm on Twitter. Feel free to DM me or at me. I'm also on Discord, and I'll be watching this throughout the day. Thanks so much.
Awesome. Thanks so much, dude. That was great. Some excellent tips there for chaining bugs, which is something I guess it's been noted in a lot of bug bounty programs. People are not doing. That was totally awesome. Do we have any quick questions before we move on? Does anyone in the Twitch chat or on the Discord have anything they'd like to know?
I had a DM come in just now asking if my slides are public. If you go to my profile on Twitter, it should be on there somewhere. I'll also try and put it on my website. I think they are on my website as well. I don't know if you guys plan on posting the videos, but that was another question that came.
Yep, we do. No, we do. Hold on one second, actually.
Cool.
What are good internal SSRF endpoints to try apart from the metadata endpoint? You can always just scan every single internal IP address, like 10 ... and you can do that through using Burp Suite or whatever other tools you use. I always go to GitHub and look for the internal corporate domain. So if they have something like ci.corp.site.com, that's the first thing I'm going to hit. So those are things that you can also look. GitHub is a really good way to find internal host names and IP addresses when it comes down to SSRF.
Yeah, I noticed as well, you mentioned Shubs in your thank you. Like Shubs has also put out some really cool ways to encode IP addresses, so for lowering your payloads and stuff like that.
Yeah. He actually did a
also
really cool research on the Jira Confluence exploits, and that's kind of why I've got an interest in the whole Jira Confluence exploitation as well.
Yeah. Atlassian's always a tasty target, I think.
Absolutely.
All right.
Yeah, thanks, Nahamsec, for coming in and hanging out. That was really cool. I really liked your demo video. It was very stylish.
The mad aesthetic as well.
Yeah, I really dug it. Yeah, thanks for coming and hanging out. So next we got Ilya, who's going to be talking about some really cool stuff.